Yeah, look.
trying to
Yeah, yeah, yeah.
investigate, like, okay, what is happening at the singularity? What is this kind of holographic projections on a plate? These weird freaking things that are out there in the universe, and like somehow accidentally they start to figure out something weird,
Weird, yeah.
and
Oh,
then
oh,
all of a sudden
there's weirdness all over the place already. Yeah, yeah,
somehow that weirdness will,
yeah,
I think on a time scale probably of 100 years or so, that weirdness will open.
yeah.
So it just seems like nuclear fusion and black holes and all of this are they're next door neighbors a little bit
Yeah,
too much for like you'll find something
yeah.
interesting.
Well, let me tell you a story about this.
Yes.
Okay, it's a real story. Okay. So there were really, really clever scientists in the end of the late 1800s in the world. You talk about like James Clerk Maxwell, and you talk about Lord Kelvin, and you talk about Lorentz, actually, who named after these other ones, and yeah, on and on and on, and like Faraday, and they discovered electromagnetism. Holy cow! And it's like they figure out all these things, and yet there were these weird things going on that you couldn't quite figure out. It's like, what the heck is going on with this, right? But we teach this all the time in physics classes, right? So what was going on? Well, there's just a few kind of things unchecked, but basically we're at the end of discovery because we figured out how everything works.
Mm-hmm.
Because we've got basically Newtonian mechanics, and we've got Maxwell's equations, which describe basically how matter gets pushed around and how electromagnetism works. Holy cow, what a feat. But there are these few nagging things. Like, for instance, there's certain kinds of rocks that for some reason, like if you put a photographic plate around it, it like gets burned or it gets an image on it. Like, well, where's the electromagnetism in that? There's no electromagnetic properties of this rock. Oh yeah, and the other thing too is that if I take this wonderful classical derivation of how something that is hot, about how it releases radiation, everything looks fantastic, perfect match. Oh, until I get to high frequencies of the light, and then it basically just the whole thing falls apart. In fact, it gives a physical explanation which is total nonsense. It tells you that every object should basically be producing an infinite amount of heat.
Mm-hmm.
And by the way, here's the sun, and we can look at the sun and we can figure out it's made out of hydrogen. And Lord Kelvin actually made a very famous, calculation, who was basically one of the founders of thermodynamics. So you look at the hydrogen. Hydrogen has a certain energy content. You know the latent heat, basically, of hydrogen. We know the mass of the sun because we knew the size of it. And he conclusively proved that basically the sun could only make net energy for about 2,000 or 3,000 years. So therefore, all this nonsense about like deep is like, because clearly the sun can only last for 2,000 or 3,000 years. If you think about and this is basically the chemical energy content of hydrogen, and what comes along in 1 decade. Basically, one guy sitting in a postal office, in Switzerland, figures out that all of these, Einstein, of course, which was like figured out all this, took these seemingly unconnected things, and it's like, boom, there it is. This is what, it wasn't just him, but it was like, there's quantum physics. Like, this explains this other disaster. And then this other guy, my hero, Ernest Rutherford, experimentalist, did the most extraordinary experiment, which was that, okay, they had these funny rocks. They emitted these particles. In fact, they called them alpha particles. Alpha, just A in the alphabet, right? Because it was the first thing that they discovered. And what were they doing? So they were taking these alpha particles, and by the way, I do this to all my students because it's a demonstration of what you should be as a good scientist. So he took these alpha things, and he was a classically trained physicist, knew everything about momentum scattering and so forth like that. And he took this, and these alpha, which clearly were some kind of energy, but they couldn't quite figure out what it was. So he said, let's try to figure that. We'll actually use this to try to probe the nature of matter. Mm-hmm. So he took these alpha particles and a very, very thin gold foil. And so what you wanted to see was that as they were going through, the way that they would scatter based on classical, in fact, a Coulomb collision, based on classical mechanics, this will reveal something about what the nature of the charge distribution is in matter, because they didn't know, like, where the hell is this stuff coming from? Even though they'd solved electromagnetism, they didn't know, like, what made up charges. Mm-hmm. Okay, very interesting. On through it goes. And so what did you set up? So it turns out in these experiments, what you did was, because if these so-called alphas, which actually now we know is something else, as they go through, they would deflect. How much they deflect tells you how strong an electric field they saw. So you put detectors, because if you put like a piece of glass in front of this, what will happen is that when the alpha particle hits, it literally gives a little boop, a little boop of light like this. It scintillates, a little blue flash. So he would train his students or postdocs or whatever the heck they were at the time. You have to train yourself, because you have to put yourself in the dark for like hours to get your eyes adjusted. And then they would start the experiment, and they would sit there and literally count the things. And they could see this pattern developing, which was revealing about what was going on. But there was also another part to the experiment, which was that it's like, here's the alphas, here's the source. They're going this way. They could tell they were going in one direction only, basically. They're going in this direction. And you put all these over here because you want to see how they deflect and bend through it. But you put a control in the experiment, but you basically put glass plates back here, because obviously everything should just deflect, but nothing should bounce back. So it's a control in the experiment. Mm-hmm. But what did they see? They saw things bouncing back. Like, what the hell? Like, that fit no model of any idea, right? But Rutherford like refused to like ignore what was a clear, like they validated it, and he sat down, and based on classical physics, he made the most extraordinary discovery, which was the nucleus, which is a very, very strange discovery. What I mean by that, because what he could figure out from this is that in order for these particles to bounce back and hit this plate, they were hitting something that must be heavier than them, and that basically something like 99.999% of the mass of the matter that was in this gold foil was in something that contained about 1/1,000,000th of the volume of it. Mm-hmm. And that's called the nucleus. And you talk about, so how revealing is this? It's like, this totally changes your idea of the universe, because a nucleus is a very non-intuitive thing. It's like, why is all the mass in something that is like zero? Like, it basically is the realization that matter is empty. Mm-hmm. It's all empty space.
Yeah, and that changes everything.
And it changes everything. Until you had that, like you had steam engines, by the way, you had telegraph wires, you had all those things. Yeah. But that realization like opened up, those two realizations opened up everything. Like lasers, all these think about the modern world of what we use. And that set it up. So all I would point out is that there's a story already that sometimes there's these nagging things at the edge of science that, you know, we pat ourselves on the back and we think we got everything under control. And of course, that, by the way, that was the origin of also think about this, that was 1908. It took like another